Hello everyone, we are back, and this time we are going to talk a little bit about neural networks with a more detail, right? So you have seen it a little bit on a high level, and I'm going to touch a little bit how it works, but I highly recommend you to check out this project and my course on Udemy. It is a free course, and you just check it out and you're going to learn a lot about how to implement neural network and learn how it works under the hood. And you are comparing our, let's say, vanilla version with TensorFlow, so that would be very helpful you to understand more about deep learning professionally. Okay, so we're gonna talk a little bit about neural networks and artificial neural networks, right? And basically it follows this, let's say, this structure, and we call this layers, and each one of those it is called neurons, right? Or perceptrons, but neurons it is more used. Okay, and each neuron contain weights, and the calculation, and depending on the input, would be used to calculate against the weights, and the output of our neurons would feed the next layer of feed each neuron from the next layer, and that's it's called feed forward. And because we give input, we calculate this input and feed an output of this layer would feed the next layer, and so on and so forth. That's why you call this process of feed forward. What it is back propagation? It is the fact that when you get to the output layer, we will calculate how far the answer from our artificial neural network it is from the expected result, and you will have some calculation that you can identify how far that is, and based on this loss, it's how it's called, we will be sending back that loss to the each layers, and based on the loss our let's say neuron would recalculate the weights that would be optimal to get a better result here on the final layer. So when you talk about an artificial neural network, there is three main operations. It is first find the architecture of your artificial neural network or your model, and when you talk about architecture, it is basically defining the amount of neurons and the amount of layers to your model. Each model requires different architecture. The second thing, it is the process of calculate the errors. So you need to come up with one loss that would be able to calculate the difference of what you're expecting from what is the output of your model, and based on this calculation we will feed forward and recalculate each to optimize your model, and that's basically that. So how this process happens under the hood, it is the interesting part. So when you are working with frameworks, you don't need to know much about it. You just choose your architecture and you choose your function loss to calculate the loss or the difference of your output, and you prepare your data, and that's it, and just start training, and as simple as that. Obviously there is some other techniques to kind of improve the performance of the model, but in a nutshell, that's it what about artificial neural network. And let me show a code very quick how we set up that structure here, right? In our case, we basically have this structure to set the layers and the amount of neurons. So each one here, it is one layer, and the number that we see, it is the amount of neurons. In our case, the first layer it would be 5 and 6 and 4 and 4, because how we came with those values was the input. It is the our, let's say, when you talk about the car, the input, because we are talking about the car, the input is the sensor, and the sensor has 5 inputs, right? Left, right, and forward. So if you look at the car itself, you have 5, 1, 2, 3, 4, 5 inputs, and that's why we choose 5. And why we have 4, it is because we have 4 options. We go to the right, we go forward, backward, and left. That's what it is for. So that's what the number comes from. And the inside here is arbitrary number, and you need to kind of explore the different options and do the training and evaluate each performance to come up with the best option here. And the input and the output comes from what it is the input that you have for your model and the output that you expect. And it's basically that. So we have here our neural network, and that's what is neural network. It's a simple class that will be basically, let's say, have one method that's feed forward, right? And that we spoke here, right? Feed forward, we only have that method. We don't have back propagation because we don't use this strategy on our case. But if we look at our other example here, that is the neural network, we also have the same neural network and we have the feed forward. It's basically the same what we have in our Neuroevolution. However, this class neural network, it is extended to trainable, to do a trainable. And when you do a trainable, you need to have one new method, which is fit or training. That's the process of using backpropagation as the training way. So, and do the feed forward, right? But then when you go to the end, we get what we're expecting and we calculate the loss of what it is the output and what we're expecting, and based on the loss we update all the weights across all the layers. And just to exemplify here, we go through all the layers, and you calculate the gradient for each layer and you update the weight for the layer itself. It is basically what we said that would be happening here. And if you want to learn more how the things work under the hood, you can go and investigate this class. As I said, I talked more about this, explain better, but just look at the code, you learn a lot. So, but yeah, there is a cost is free and you can get more information there. So that's it, basically the neural network. And I'm gonna just go back to the process of the crossover when you are executing. So now you know that there is the layers, and maybe when you go to our evolving crossover thing, you understand that you have the layers and you have the weights of the layers that it's used to calculate the output of each neuron, right? So, and that's what we're doing here. It is basically using dad's weight sometimes and the mom's weight, and the same for the bias. Okay, I hope that has helped to understand a little bit more about what's the neural networks. As I said, there was a very brief introduction, so you want to learn more, please visit my course here and you're gonna have more explanation about the whole process. And so that's its backpropagation, and we already saw that we are not using backpropagation, we are using the evolution, which is just most simpler. There is no backpropagation, it's just choosing the weight that was already randomically generated to the parents of the population. And that's it. So very simple and very, very interesting as well, right? So you can achieve amazing results with very simple techniques. Thank you. See you later.